couple of comments there on it. So, with that. Same thing when you're looking at up here, and you see those little blocks up there. That means I'm dragging that yield outside of my field. That's what's going on here. Okay, that's pretty much all I've got for yield mapping and the assignment. I am going to cover some other things when we get into this PAMRI report. And there's an interesting techniques for determining transport lag and instantaneous yield. But how do you calibrate a yield sensor? Talk about calibration of a yield sensor. How do you calibrate a yield sensor? Well, here's how you do it. You're in your field. You start to enter the crop. You hit a button to say start calibration. You go through a whole row, or maybe even more, and you hit a button that says stop calibration. Then you take what you've combined and you weigh it, and you get a set point. Okay. Now here's what you've just done, and that's the standard calibration routine from everything I've seen and read, and that's what we do when we calibrate our yield sensor. The problem with that is that the combine yield sensor is a rate or a flow sensor. It's an instantaneous sensor. The technique to calibrate it is a batch style. I'm collecting data for a certain period of time, and now I'm weighing that data. So you're relying on, you're calibrating a flow sensor or a rate sensor using a batch technique. And anytime you do that for any sensor, you get into trouble, potential trouble. You're relying on linearization. You're relying on the fact that there's a linear relationship between mass flow rate and the output of my sensor. And you're not calibrating that with any sort of flow, which is very difficult to do. I don't know of a better way, but I just know that that has potential problems with it. But that's the way you do it. And most people, and so what will happen is most people will evaluate a yield monitor by capturing your on-the-go yield maps, add them up just like you're going to do, and then compare it to the full weight of what was combined. And they'd say, well, if this added up, in terms of my yield sensor said I've got so many bushels harvested from this thing, and that's exactly what I get out of this field is so many bushels, it's accurate. I don't know if that's true or not. Because I'm trying to figure out yield at a certain point, and this is the average yield for my field. Now again, I don't know the best way to do that. I don't know a better way to do that without some kind of in-lab situation. But that's exactly what's being done. Kentucky has been doing some work. This is the last thing I have to say. University of Kentucky. And one of the problems with this impact sensor is the fact that I'm relying on this flow of grain to hit this impact sensor. Now, if I'm on a hill like this, and that grain's flowing up, yeah, it's not going to hit it. Or it's going to hit it slower. And if I'm on a hill this way, and it's coming back here, I've got gravity coming in and I'm pounding that impact sensor because of gravity. So tilting of the combine can influence your reading. And a lot of people will have tilt sensors set up. And they'll measure, well, you have self-leveling combines, but a lot of people don't do that. But they'll have a sensor that says, am I tilted, and which way am I tilted? And then there's a little adjustment based on that. And Kentucky actually has a setup that throws grain across a yield sensor, and you can tilt it. And then you can adjust your calibration based on the angle of your combine. So those are other things that come into play when you're looking at con. A lot of times that's done internally. Okay, 3:30. I think you guys are bored enough with me. I think you have enough information to start working on that lab. I will see you tomorrow.